We are just in position to finish third chapter of class 9 physics, gravitation. But two terms are left here. What is mass in physics? What is meant by mass of a body? So definition of mass is the amount of matter contained in it. The amount of matter contained in a body is called its mass. Is called its mass. The amount of matter, the amount is quantity. When there is quantity of matter contained in this, unit of mass is gram or kilogram, kilogram. SI unit is kilogram. I have told you what is 1 kilogram. It is mass of a platinum cylinder placed at weights and measure office at Sèvres near Paris, which is in France, because MKS system is developed there and unit of mass is taken from MKS system in SI, Standard International. So platinum cylinder kept at the weights and measure office of Sèvres near Paris. Sèvres is a place near Paris where an office of measurements is there. Unit of mass is gram or kilogram. Kilogram is SI unit of mass. 1 kilogram is equal to 1000 grams. Other sub multiples of kilogram and multiple quintal tons are there. You might be familiar with that. Second term is weight. Weight of a body. Weight of a body is the force by which body is attracted towards the center of Earth. It is force. The force, the force by which the body is attracted by Earth. kg weight, and also ground weight also, and many other units are there. There is some difference between mass and weight, which can be written in the form of table in your book. the difference is given. 4 differences are given here. See, it is Lakhbir Singh and Manjit Kaur book. Difference between mass and weight. The mass and object is the quantity of matter contained in it. First, and in weight, first thing is weight of an object is the force with which it is attracted towards the center of object. Definition of the topic. SI unit of mass is kilogram, which I have given here. SI unit of weight or force is Newton. Mass of an object is constant. Third point, it remains constant. In your book it is given mass of an object is constant, but you write remains constant. Always remains constant. Either you find your mass on Earth, on Moon, on Mars, or anywhere in this universe, it will remain constant. But weight of an object is not constant. It changes with the change of position or acceleration of the place. Acceleration to gravity or acceleration. The mass of an object cannot be zero, can never be zero. Weight of an object can be zero. Example, in space where g is zero, then weight becomes zero. In spite of this, mass is measured by beam balance or physical balance. Weight is measured by spin balance. In this chapter, I told you that our weight, which is here on Earth, will be 1/6 on Moon. But mass will remain same. If you find your mass by beam balance, if you are suppose 50 kg here on Earth, if your mass is 50 kg on Earth or anywhere, because it remains constant, then weight of yourself, if you find on Earth, it will be 50 into 9.8 Newton. That is, it becomes 544, 545 and 449. These may be Newton. Under 50 kg weights person will weigh 490 Newton or 50 kg weight. But on Moon, if you go, it is 50 into what is acceleration due to gravity at Moon. I have told you acceleration due to gravity at Moon is 1/6 of Earth acceleration gravity into 1.63 Newton. So it is how much? This 0 goes here. It is 5 meter 15 and 5 meter 30 and 1. 31 3, 5 meter 5 and 3, 81.5. 1/6 of that. You divide by 6. It is 4 8 48. sorry. 6 how much? 6 times. So 6 in divided 490 divided by 6 is 6 8 48. 8 comes. Then 1 is remainder here 0. 6 1 that 6 4 is remainder 40. Then 6 6 about that it is 1 6 times. On moon your weight will be 21.5 Newton by spring balance. On earth your weight will be 490 Newton by spring balance. But by beam balance your mass will be 50 kg. So beam balance is this way. Just yes, on belt before this is beam balance. A beam is there. Beam is there. String, two strings are there. Fans are this way. Here is another hook. Two strings likewise. Here. Some point or these are fans. So by this instrument mass is measured because on both acceleration of the planet on which you are finding your mass cancels out. But the spring balance is like this. It is containing here hook. One hook is there. Likewise, here suspension is there. Very screen is there. Attached here. Here is some indicator and there is transparent scale. Screen nut becomes visible. On this scale, divisions are there. These divisions will give your weight. It is spring balance. It is beam balance. So mass is calculated by beam balance. Weight is calculated by spring balance. Because we have finished 3 chapters here. Third was gravitation. Let us do some questions and some numericals, and if our classes will start, we shall revise with you to make it more clear, and then 2 more chapters will be there in physics. In mathematics, generally, more than half we have covered, but still many things are left. There you see, it is spring balance here. This one is spring balance. Weight is calculated by spring balance. It is given in page 97 of Lakshmi Singh's book. And this one is beam balance. I have made a rough figure. It is beam balance. This is physical balance, or this is also called beam balance. More accurate beam balance. Mass and weight are given here. And at the last of this chapter, let us do some questions of the chapter, because now we are so. The time which we will get here, we shall do some questions, because we are on the eve to open the classes by the permission of your guardian as per government order. So, what is value of gravitational constant G on Earth and on the Moon? Question is, what is value of capital G value remains constant. Whether on Earth or on any planet, capital G is 6.67 into 10 to the power minus 11. Unit is kg. Okay. Unit is G is equal to relation is F is equal to G m1 m2 upon r square. So m1 m2 is process, kg is meter is Newton, meter square, kg to the power minus 2 or by power. This is unit. So whether on Earth or Moon or anywhere in the universe, this will be constant. G changes. Small g on Earth is 9.81 meter per second square. It is on Earth. But on Moon, it is about given that 1.26, I think. So, don't confuse. Very good question is here. What is value of gravitational constant, universal gravity? Which force is responsible for Moon revolving around the Earth? That is gravitational force between Earth and Moon. Okay. Does the acceleration produced in freely falling body depends on the mass of the body? Answer is no. It does not depend on mass because Newton has shown his experiment, Guinea feather experiment, that a guinea which is heavier, many times heavier than a feather, in vacuum both fall simultaneously from top to bottom. Name the scientist who gave the 3 laws of planetary motion. Such questions should not be asked. Name the scientist. Planetary motion 3 laws has been given by Johannes Kepler or John Kepler. So, answer of question is this, John Kepler. Name the scientist who explained the motion of planets on the basis of gravitational force between sun and planets. Motion of planets on the basis of gravitational force. So, this was explained by Sir Isaac Newton. State Kepler's law, which is represented by the relation r cube is proportional to t square. It is Kepler's third law. It explains that radius of the path in which planet rotates, so cube of radius is proportional to the square of the time period which it takes in revolving round the sun. So these are some questions, many questions are there. Let us do one or more numericals here. Some I have done there. What is force of gravity on body of mass 150? Some I have done here. numericals. Yes, one filling the blanks is there. Let me do that because it may be difficult for you. Question 26. On page 101 of Lakshmi Singh. Fill in the following blanks with suitable words. First is, this is given in your book, number 26. The acceleration due to gravity on the moon is about 1/6 of that on Earth. I have explained it many times to you. So write 1/6 of that on the Earth. In order that force of gravitation between two bodies may become noticeable and cause motion, one of the bodies must have an extremely very large mass. Because I told you that G is such a figure, so unless the product of mass is greater than 10 to the power 11, if considerable force of attraction will not be seen. So extremely large mass. Weight of an object on the earth is about 6 times. It is similar to question 1, that where is 1/6, here is 6 times of weight on the moon. The weight on an object on the moon is about 3 times it has actually. It is 1/6 weight on earth. C and D, 2 questions, 2 part of 26. In C you have to write 6 times, in D 1/6 times, because reverse is asked. The value of G on earth is about 9 or 1/6 of that on the moon. About 1/6 on earth is 6 times that of moon. E is 6 times. If the weight of body is 6 Newton on moon, it will be about 36 Newton. On the earth it is last one, F. So you fill this blank, and we can do some more questions here. I have done some. Yes, one question is here. 55. A good numerical but very difficult numericals are not involved. Question 55, page 102 of your Lakshmi Singh book. Here, mass of planet is 6 into 10 to the power 24. 24 K. Mass of planet. And diameter means twice of radius is 12.8 into 10 to the power 3 kilometer. If the value of gravitational constant is capital G, it gives 6.67 into 10 to the power minus 11 Newton meter square per kg square. Then it says acceleration, find acceleration due to gravity. Here I have shown you force that is M into G for an object. G M planet small m, small m. G M it is on the surface. So these two cancels. So G is equal to G is 6.67 into 10 to the power minus 11. Mass is given 6 into 10 to the power 24. And the radius will be half of that is 6.4. It is in kilometer. 10 to the power 6 meter. Actually, this is mass of Earth, this is radius of Earth. So the value which you have calculated will come same. But if such questions are asked, you will not cite that it is based on it is for the Earth, because you have to do whatever is indicated. Here is 24, here is 11, 6 is there. 10 to the power 13 is left here, and it will come 6.4 into 6.4 into 10 to the power 12. 10 to the power 12 plus this 10 is left over there. Then product of these two and product of these two is a quantity less than 1, so it becomes equal to 9.8 meter per second square. This is numerical for Earth. Actually, mass of Earth is given and its radius also, but name of Earth is not given, so you might get confused here in doing that question. So here are some numericals in gravitation. Some questions are discussed. You go through the questions in the book and learn the laws and phenomena which I have given to you properly. And if problem arises, you can ask with me. Then some more things are here. Density, relative density, and other things. Rotation. Here, question 48 on page 125 is, why do camel have large flat feet? I told you here, see, the feet of camel is shown, large flat foot of camel. Camel is here. It asks why it has a flat and large feet. Feet is quite large. See, this way it has shown. This way, such a large feet of camel. Here it is like a bird, large feet of camel. Below is sand. Here is sand particles. So, you know, mass of camel is constant, suppose it is m, and its pressure on the ground depends on thrust upon area. Mass into g, m into g will be thrust, and area is area of the field by which it presses the sand. So if large and flat foot will be there, it is larger and flat in the sense it is wider. If area is more, then pressure will be less. So camel will sink less in the sand with in spite of the other animals or than the other animals which have mass half of camel, but whose food or whose feet, if we consider one foot put one leg or other leg than feet. Suppose any animal has mass half of camel, but area is its feet is flat and large, but its area is A by 8, like horse or cows. Then what will happen? Pressure will be mg into 4 upon it. 4 times more pressure it will produce, and the animal, horse or cow or other animals which have even weight less than camel will sink more in the sand, and it will be very difficult for them to walk properly. That is why camel is called sheep of the desert. So many questions can be done. So I shall do questions in the future also. Let us stop over here.